EHAD stands for Electrical Hydraulic Analogy Demonstrator, which is what this project is based on. This analogy is used because electricity can be very hard to understand because it cannot be seen. Therefore, this allows a comparison between electrons within electricity, for example within cables and overhead lines, and the particles within water which can be seen, for example in a turning water wheel, allowing a greater understanding of what is actually happening within an electrical circuit. The key areas of this analogy that must be understood are that electrical voltage equals pressure in the hydraulic circuit and electrical current equals flow rate. Using this, any electrical component can be created hydraulically, with the water going through it acting as the same as the electrons would.
The resistive design we decided to employ was a large valve which mimics the behaviour of a variable resistor. As the handle of the valve is turned, the internal ball joint begins to rotate, resulting in a reduction of the water flow through the valve. This emulates the behaviour of current through a variable resistor. As the resistance is increased, the current reduces through the resistor. The capacitor design consists of two 50mm perspex tubes screwed together through outer flanges with an elastic material between each tube. This material deflects when subject to the water flow, which imitates the capacitor charging up. When the direction of the source is reversed, the water begins to flow the alternate direction, which allows the elastic to retract back to normal, which pushes water stored within this through the circuit, discharging the capacitor. It's this process of charging and discharging which helps to smooth the AC signal into a DC signal.
The transformer utilises a source piston pair to turn a gear chain in a rack and pinion configuration which drives a secondary piston pair. The gears show the turns ratio present in transformers, and the piston pairs ensure a transformer operates for an applied AC input only. This will give a good visual showing of how power is transferred through a transformer. The rectifier uses one-way valves to funnel water from the two channels of the AC source through one section of pipe. The system is configured so that the pressure will build up in this section and allow the capacitor to operate. The demonstrator will give a good account of how a rectifier converts an AC input signal into a DC output signal.
To achieve a system design of the desired level of quality, the group actively pursued industrial sponsorship from a variety of companies that either operated within the power engineering sector or those with a keen interest in inspiring young people into STEM. After being impressed by our initial concept, the electrical network operator, SPNG Networks, were happy to fulfil the group's project budget. In return, the company's branding was placed on the system and the demonstrator could be used at future STEM-oriented events. We'd like to thank SPNG Networks for their generous contribution and their commitment to STEM learning.
According to Engineering UK and the Royal Academy of Engineering, there's currently an annual shortfall of up to 59,000 engineering graduates and technicians to fill core engineering roles. Furthermore, Engineering UK state that of first degree entrants in engineering and technology, only 16% are female. Despite these careers being incredibly attractive with higher employment rates and higher mean starting salaries than the UK average, more must be done to attract talent into these professions. It is the purpose of this project to tackle these shortfalls by introducing school students to engineering in an exciting and engaging way. We wanted to create a hands-on experience that would engage school students of all ages, whilst also providing a deeper level of understanding for those in the final years of secondary school. For those earlier in their school career, Ohm's law and how a resistor and capacitor work would be an appropriate level to teach, and those in 4th to 6th year could be given more complex lessons on how transformers and rectifiers work, how stepping up voltage reduces losses over a long distance transmission, and the purpose of implementing rectifiers.
Choose engineering. Be the difference.